Hello everyone. So welcome to this Azure developer community. So today we have a very amazing speaker and very experienced one. So today we have Nilesh sir here. So Nilesh is an active community member and he is awarded with Microsoft Most Valuable Profession since 2018 for Azure for excellent contribution to technical communities. So he had already given various talk to conference and forums, and he's co-organizers or Microsoft Azure Singapore user group, hosting meetup event and organizing global events such as Global Azure Boot Camps. So he's a certified Azure solution architect and expert also. And basically, he's a good experience on DevOps world and Azure data engineer as I said. So in this session, we're going to learn a lot from him, and I hope that I sure that this session will going to be very insightful, and you guys will going to learn a lot from this session. So first of all, thank you, Nilesh, for being here and joining this session. So yeah, so now stage is yours. You can start now. Thank you.
Thank you. Thanks for the introduction. Before I start, can you see my screen and can you hear me clearly?
Yes, I can hear. I can see the screen also.
Okay, perfect. So let's get started. Today we'll be talking about auto-scaling containers with event-driven workloads. And before we start with that, quick introduction about myself. I have got almost close to 2 decades of experience in the industry. And as mentioned, during the COVID period, I utilized some of the time that I saved on traveling and uh, working from home. I managed to clear some certificates. Recently, I cleared the certified Kubernetes administrator and application developer as well. And on my YouTube channel, you can find some tips on how to prepare for these certificates in case you are interested in taking any of these certificates. I'm also quite active in the blogging space, and I like to talk a lot about technology. When I'm not talking about technology, like most of the other Indians, I enjoy the game of cricket, and uh, I do watch a lot of cricket. I'm also the co-organizer of Azure Singapore user group, where we have been doing sessions for past many years. And since COVID started, all our sessions have been virtual, which has given us opportunity to bring in speakers from across the globe. So I've given a bit.ly link here as well as QR code. You might find some sessions from industry experts like Scott Henselman, then Donovan Brown, so many people in the industry who have come and presented at our sessions, and all these are available on our YouTube channel. So please feel free to subscribe to that channel. A bit of background about my origin. I was born and brought up in Goa. I did my schooling, everything in Goa. And if you have seen many of the movies, you would see that mostly Goa is shown as a place where it's good to enjoy. It's a good vacation spot. And you will find that most of the Bollywood movies show Goa in very beautiful sites, I would say. And mostly it shows the churches of Goa, but Goa is not just limited to churches and drinks. There are also, and beaches, obviously. There are obviously some historic temples as well. So, in case you visit Goa, I would suggest that do visit some of these historic places. So, now coming back to today's session, what we'll be covering is we'll start with looking at what are the options for scaling in Kubernetes. We will look at a project called Kubernetes-based event-driven auto-scaling, or KEDA. We'll have a quick overview of that. We will have a live demo, which is related to an application called Tech Talks. So you can think of that as a small demo application dealing with management of the talks. And then we will see how KEDA can be used. And we'll also do a sort of deep dive into the architecture of KEDA. So before I start the session, there are some prerequisites. Since we are talking about Kubernetes, Docker is like uh, essential thing here, or containers for that matter. If not Docker, some sort of container knowledge is required. So Docker helps us to containerize the application. It's a self-contained application with all its dependencies and packages. It's a sort of packaging mechanism, which has become quite popular over the last 6 or 7 years, I would say, or close to 10 years. Then Kubernetes, which is the orchestration platform, it's the de facto orchestration platform now. Most of the cloud native applications are using some form or the other of Kubernetes, and it has various things like it orchestrates the containers in the first place. It has self-healing capabilities. It gives service discovery and scaling as well, among many other things. Then a bit of knowledge of container registry is required. So this is like GitHub or a Git repository, but for container images. So you could be using a public Docker Hub container registry, or it could be a private container registry hosted within your organization, or like the ones provided by cloud provider. Azure has, for example, Azure Container Registry. There is similar registries provided by GitHub and AWS and many other providers as well. And finally, a bit of knowledge about Azure Kubernetes Service, because that is what I'll be using here. So it's a managed Kubernetes environment provided by Microsoft Azure and has native integration with various other Azure services like Azure Active Directory, Azure Container Registry, Azure Container Instances, Azure Monitor, and others. So let's start by looking at what are the different options when we want to scale something in Kubernetes. So basically, the lowest unit or the smallest unit of uh, execution in Kubernetes is a pod, and there is a concept or a feature available which is called as horizontal pod autoscaler, which is called as HPA. This works on the basis of having a limit or having a range set for things like your memory consumption or CPU usage. Based on that, we can say a particular pod or particular deployment has to scale between a certain range. So let's say when I'll show you an example later during the demo. If let's say our CPU usage goes above 75%, for example, we want to scale from let's say minimum replicas of 5, and the top limit we want to put is 10. So when the workload decreases, it would again scale back down, and it would work within this range. Once we have, let's say, enough number of pods running, there could be a situation where you need to scale the whole cluster itself. That is where your current resources within the Kubernetes cluster is not good enough, and you need to add more compute power or more resources to the cluster. And AKS or Azure Kubernetes Service, for example, has a feature where you can turn on the Autoscaler, and it will monitor your resource usage for existing workloads. And if there is a need, it will scale up. And when there is no need, it could scale down again within a range of nodes using this cluster Autoscaler. Third thing is manual scaling. So you might have come across situations where you have some expert in your team who's been there for quite a long time, and they know the seasonality on when something has to be scaled. So it could be like on a quarterly basis or a monthly basis. So someone knows when the scaling has to happen, and then you go and manually scale your workloads. So let's get into a demo mode and see how we can use some of this. So for this demo, I'll be using, as I said, a Tech Talks application, or application which is named as Tech Talks. There is a producer in this. This is a .NET Core API. It has two replicas, and it is exposed using the Kubernetes service object, which is provided by Kubernetes. And there are different types of services that we can use in Kubernetes. So I'll be using a load balancer type of service, which allows us to have a public IP for this service, and we can then invoke that service from outside the Kubernetes cluster. This is running in a Docker container. So our web API is packaged as a Docker image, and we'll be running it on the Kubernetes environment. Next is the consumer part, which is .NET Core EXE. And this is not exposed outside the Kubernetes cluster. So we are not creating a service here. We just create a deployment, a type of object again in Kubernetes, which is a higher level construct, which allows us to create multiple replicas of the same pod if required. And this consumes a set number of messages. So there is a configuration which allows this particular consumer to pick a certain batch of messages from a RabbitMQ, and it will process those messages. And finally, the middle tier or the messaging layer, which is RabbitMQ. This is also deployed inside a Docker container, and we use Helm chart. So Helm is like a package manager. When you have an application with a lot of internal dependencies, or there is certain ways of creating different resources required for application, it's always advisable to use a sort of package manager. And when it comes to Kubernetes-based application, Helm is that package manager which is used. So Helm uses something called as charts. So charts are like your application in Helm. So I'll be using a Helm chart to deploy a RabbitMQ in my Kubernetes environment. And this again exposes a service internally. Once the Helm is finished its deployment process, RabbitMQ will be available as a Kubernetes service. So our application, both the producer and consumer, would be able to consume messages using this service, or would be able to interact with RabbitMQ using that service. So this is the overall demo setup. We have the producer, consumer, and RabbitMQ. And then what we'll be using is a set of deployment and service. We'll be using these deployments and services are deployed using the Kubernetes manifest files, which are YAML files describing in a descriptive manner what should be the configuration and settings to deploy these objects. Then we use Helm, as I said, for deploying third-party services, which is the RabbitMQ here. For visualizing the state of the Kubernetes cluster, we'll be using I was using Octant in the past, but recently I came to know about another uh, tool called Lens. It's an open source tool which allows us to visualize what's happening inside the cluster. And for deployment, we'll be using kubectl or kubectl, and we'll also use Postman to generate the work. So let's get into the demo mode, and let me switch to the terminal. So let's start by looking at those scaling things which I talked about now. So before I show the scaling, maybe we can quickly look at the state of the cluster. So this is the Lens tool that I was talking about. We can see what are the current workloads running. There is a RabbitMQ. So I'm looking at pods which are running right now. We have a RabbitMQ stateful set, which is controlled by stateful set pod. It's named as RabbitMQ0. Then there is one instance of RabbitMQ consumer, and there are two instances of RabbitMQ producer. In terms of deployment, within the default namespace, we have a deployment named as RabbitMQ producer, and we have a deployment named as RabbitMQ consumer. So let's start by the first demo, which I talked earlier about manual scaling. So we can scale using a kubectl command. I'll be using some form of aliases here to reduce the typing, but these are basically running kubectl scale deploy command, and we will have, instead of one, let's say two replicas of our consumer. So currently there is one instance running. I want to increase the number of replicas and make it as two. So I say the thing that I want to scale here is deployment or type of Kubernetes resources deploy. And the name of that resource is RabbitMQ consumer deployment. And I want the replicas to be two. So when I do this, the number of replicas for deployment would scale from the current one replica to two replicas. So once it is successful, we can go back to Lens and confirm that we have two replicas. So we can see that this particular deployment has been scaled. So if we go back to the Lens now, we should be seeing two replicas. So we can see here two of two pods. There are two replicas and both the pods are ready state. So let's generate some workload and see how this works. So I have this API, which is exposed on this public IP. And it has a method called generate, and it takes the number of messages that we want to generate. So let's say we will generate, in this case, 4,000 messages. And we also have a UI to see the state of RabbitMQ. So if we go to the browser, there is a RabbitMQ UI which is available. When I deploy RabbitMQ, uh, I can access this user interface. So we can see that right now there is nothing in the queue. The queue is empty. There are no messages and everything is zero. So let's go and generate this workload and let's send 4,000 messages into the queue. So we got status 200 OK, which means that this particular API call was successful, and we should see those 4,000 messages coming here. And we can see that 150 of those messages have been picked up because the batch size that I have specified for the consumer is 75. So each consumer is picking 75 messages in one batch, and that is why we have 150 messages been picked here. So to confirm that this is working fine, what I've also done is my consumer is writing sort of logs, which we can see using the pods which are running here. This is another good feature of Lens, which allows us to quickly go into the pod. Otherwise, we have to use kubectl, for example, and then fire the logs command and then give the name of the pod. Instead of that, here is a visual way of quickly seeing all the pods, and we can also see the logs there. So if I click on the pod logs here in the output below, we should see a stream of logs coming in. So it says that once the message is picked up, there is a slight delay of 2 seconds between the messages. So every 2 seconds, one message is picked or one message is processed from that batch of 75 messages. So it will write what is the tech talk which is persisted, what is the content of that. Like it contains an ID, it contains a category, it contains a level. So based on that information, it will write this into the log. So this gives us an idea that, okay, these messages are being processed. Now, if we go back to the RabbitMQ UI, we can see that only two consumers are running. And as I said, we can configure a horizontal pod autoscaler to scale based on the resource consumption. So what I want to do now is I want to scale this consumer to say go up to 10 and let's say minimum 5. So I want to do that scaling or auto scaling. So I can say kubectl auto scale deployment. So again, we are targeting deployment here. Same deployment, RabbitMQ consumer. And if the CPU percentage is equal to 75%, then let's say minimum is 2 and we can go all the way up to 10. That is the range I want to work with. So once I schedule this or once I run this imperative command for auto scaling, it will create a horizontal pod autoscaler for this particular deployment. And it will start to look at the CPU percentage that is used by the deployment. So it says that the RabbitMQ consumer deployment has been auto-scaled. So if we look for what are the horizontal pod autoscalers available within the cluster now, we should see one horizontal pod autoscaler created with this name. Let's see if Lens has a way of showing horizontal pod autoscalers. Uh, it shows the deployments. No, it doesn't show HPA. So we can see it on the terminal itself. We can query the HPA. So let's clear the screen here and we say kubectl get, and I'll use the short form for horizontal pod autoscaler HPA. It will show us what's happening. Sorry for the slight delay. The terminal is not refreshing fast. Okay. So we have one horizontal pod autoscaler created here, and you can see that the target for that is 75%. Currently, it is at 10%, and we have the minimum of 2 pods, maximum of 10 pods. If we wait for some time, we expect that this horizontal pod autoscaler should kick in, but this will not work because currently it's taking only 10% of the resources. And the reason for that is I'm using a construct in Kubernetes deployment, which is specifying the resources. So when I create an object of type deployment, or when I create a pod, for example, I can specify what are the resources which are required for executing my pods or for running my pod. And this is given in the form of request and the limits. So I can specify a request which will be used at the time of scheduling a new pod onto a node. And then limit is as the pod start executing, what should be the maximum amount of resources it should use. So here I've specified that it should use 1% of CPU and 150 MB of memory. And the limit is 50 or 5% of core CPU and 400 MB. So because of this resource limits and the request that I've put, I will never go and hit those limits. It will never cross the 75%. And this horizontal pod autoscaler will never work. And in this case, our messages or our consumers will only remain as two. They will the currently running two consumers or two replicas. They will be only the ones which will be processing this, and this is not what we want to have in this kind of an application. So this is one of the limitation of horizontal pod autoscaler, where because it depends on the type of matrix, which is CPU and RAM. If those matrix are not hit, your horizontal pod autoscaler will not work as expected. So what we need is some other form of matrix which can be used to scale this particular consumer. And that is where the topic of today's discussion is, or the project that I'll be using comes into the picture. It is called as KEDA, or Kubernetes based event driven autoscaling. It's a project created by, it's an open source project created by Microsoft and Red Hat. And now there are other contributors contributing to this. So what KEDA tries to do is, instead of looking at purely CPU and RAM as the matrix, it looks at other factors. It can look at external matrix. So in our example, RabbitMQ, for example, is an external system which is not part of the Kubernetes resources or Kubernetes objects. So it can look at RabbitMQ and certain properties of RabbitMQ, and it can scale the objects which are part of Kubernetes. So I will use uh, KEDA, and I will run some scripts here to go a little bit faster. So let's do first thing, which is to delete this deployment, the horizontal pod autoscaler that we created. So kubectl delete, or yeah, again, I'll use the alias here. Kubectl rm is krm is kubectl delete. I want to delete that HPA. So if we delete the HPA, nothing is going to happen because we still have those two replicas of the consumer running. And now what I want to do is I want to run a script which will enable auto scaling by means of KEDA. So once this command is finished, I will run that script. And before we run that script, I also want to see what are the custom resource objects which are currently available, because this creates a set of custom resources. So if we look here, there are 4 different types of custom resources which are created by KEDA. I've already installed KEDA, so I'll show you how to install KEDA a little later. But the KEDA has been installed on this Kubernetes cluster. So it creates something called as scaled job, scaled object, trigger authentication, and cluster trigger authentication. So these objects are available in my cluster, which allows me to create a set of custom resources. And that is what we will be using as part of this script. So I have a script here which says deploy autoscaler. So this will run a set of Kubernetes manifest file. I will walk you through them as well. Okay, so it's deploying the autoscaler for our consumer. And while that is getting deployed, I also want to show quickly a watch which I have created here. The top half of the screen is watching for the pods which are running, and the bottom half is for the deployment. So we can see right now that RabbitMQ consumer deployment has two replicas running, and there are some pods running. So what we expect now is the scaling to kick in because of the enablement of that autoscaler of KEDA. And we should see this number of deployment or the replicas for the consumer deployment increasing progressively. And the number of pods which are running here, they should also increase progressively. So it looks like the pod watcher has stopped. So I'll restart it again. Looks like something happened to my network intermittently. Even the lens is restarting. Okay, let's first work with the terminal for now. So we are watching for the pods here in the top half, and in the bottom half, we'll be watching for the deployments. Okay, it didn't deploy all the objects. Looks like something went wrong just in between. Let's try it again, the same script. Okay, so this time it went through and it has created a secret. It has created something called as a scaled object, and it has created a trigger authentication. So these were the three resources that I wanted to create. And once this is created, what we have already started to see here is it is creating additional containers here, and you can see that it is also trying to scale the deployment. So initially there were two replicas. From two, it went to four. From four, it went to eight. And within a minute, it will see that again, eight is not enough. It will scale it to 16, and from 16 to 30. So the limit I have set here is 30 replicas. So we should be seeing after 16, it won't go to 32, but it will create a request for 30 replicas. And in a short period of time, we will have 30 consumers up and running. So you can see here, the last line is it's stopping at 30. So all 30 of out of 30 have been now scheduled, and all of them are running. So now if we go back to the RabbitMQ UI, we should be seeing 30 consumers. Okay, this one again had a problem. So I'm just refreshing all those port forwardings and other things. Sorry for the network problem in between. Okay. So we see that the consumers here, there are 30 consumers, and all of them are now processing 75 messages in a batch. And if we look at the number of ready messages, there are more messages to be processed. All have been picked up by those 30 consumers, and they all are processing. And as and when those messages are getting processed, we are also getting the acknowledgement and things like that. So how did all this happen? Let's go and first look at how do we enable KDA for our cluster. So as I said initially, that for deploying RabbitMQ, I was using Helm. KDA is also available as a Helm chart. So I have used Helm to deploy KDA in my Kubernetes cluster. It is available at kedacore.github.io under the charts repository. We run the Helm repo update command to get the latest version of the chart, and then we use this Helm upgrade command to install a release called as KDA. Let's zoom in a little bit. And then we are targeting version 2.4 of KDA, and we are creating it in the namespace called as KDA. So with this one command, Helm upgrade, all the resources which are required for enabling KDA on my Kubernetes cluster is successful, and that is why we are able to scale our consumer. Now, to enable the consumer to use this data, what we have to do is we need to create some manifest files. So in my repository, I have a folder called as Autoscale consumer. It needs a secret or Kubernetes secret, which is required to contain the connection string, which is your name of the RabbitMQ, what is the queue name or the topic name, and what is the user and the password. That is stored as a Kubernetes secret here. But the most important part is this, which is called as a scaled object. So this is the definition that we will look at. It's of type scaled object, which is a custom resource. So this scaled object is provided by KEDA. It's the custom resource of KEDA's resources. So that is why we have the API version keda.sh, and the kind is scaled object. Then it has the metadata like other Kubernetes objects. We have the name and the namespace where this has to be deployed. And then we say what is the scale target reference. So we are targeting our consumer deployment, the deployment that we have existing on our Kubernetes cluster. And then we override some of the default values. So you saw that scaling happening from 2 to 4, 4 to 8, 8 to 16, and 16 to 30. It was happening every minute. So that poll interval is 60 seconds here, and we can override it to a different value. 60 is, I would say, used for demo purpose, but in a real production environment, you would keep it slightly longer than just a minute. The default is 30 seconds. Then minimum replicas, I'm making this as 0. So when the scale down happens, I don't want any resources to be consumed by my deployment. Uh, by default, when we create a deployment in Kubernetes, we cannot scale it down to 0 unless we manually run that scale command. But otherwise, like a horizontal pod autoscaler, there is no option to scale down to 0. So KEDA allows us to bring it down to 0. And then max replica count is what I set to 30. That is the upper limit. And then it has the trigger, which is the link between the KEDA and what is the event source. So in our case, the event source is of type RabbitMQ, and the metadata is the metadata related to that RabbitMQ. So we have the queue name hello here. Queue length is 5, which means how many number of messages should be there in the queue for the auto scaling to happen. And then we also use the AMQP protocol, which is the messaging protocol here. And it uses that authentication ref for authenticating using the username password. So with this, KEDA is able to scale our deployment up and down. So let's see what's happening. We still have some messages, or it has gone back to 0, which means all the messages have been processed. And if KEDA worked correctly, we should also see that it should scale back down. So you can see here, it is already starting to scale back from 30. It is trying to scale back to 15, and on the top half you can see the pods are terminating. And then very soon we should see that this goes back to zero, because we said that it should the minimum count should be zero if there are no messages to be processed. And there is one more thing which I want to show. Get CRT. So we can also query the kubectl API or Kubernetes API to get those custom resources using kget custom resource definition or kget crd command. I'm not sure why the terminal is taking so long to refresh. Really apologize for this delay. So we can see here that it went to 15 for few minutes or a short duration of time, in fact, and then it went back to zero. So now we have zero replicas of the deployment running. We can also see this from the Lens UI. So if we go back to the deployment section here, we see that the consumer deployment has 0 pods running, and in the pod section also there are no pods shown for the consumer part. There are only 2 pods for the producer and the RabbitMQ. So yeah, so this is what I wanted to show using that custom resource definition. So these are the objects, the scaled object jobs, scaled objects, trigger authentication. So whatever .kda.sh is there are the custom resources which the Helm chart creates for us, and we use that as part of our deployment. So let's switch back to the uh, presentation mode and continue from where we left. So now let's talk about the KEDA architecture. How does KEDA do this? So at the heart of KEDA architecture is the matrix that it collects. But these matrix, unlike the traditional Kubernetes matrix, which are based on CPU and RAM, these are external matrix. And KEDA has this matrix adapter based on which it is able to create its own horizontal pod autoscaler. So if you remember, I deleted the horizontal pod autoscaler, which I created myself. But when we enabled KEDA, KEDA created its own horizontal pod autoscaler. So behind the scene, it is still creating a horizontal pod autoscaler, but it is managed by KEDA, and we are not managing that horizontal pod autoscaler. So it uses this external matrix, and those external matrix, they come from external trigger source or external event source. In our case, that external event source was a RabbitMQ, and scaled object is the one which makes this happen. It's a type of manifest that we create, or it's a type of Kubernetes object that we create, which I showed you has those references to the type of object we want to scale. In our case, it was the deployment, but there are other objects which can be scaled by KEDA, which we will see in the summary part. And this is how it does that. So there is an agent which activates and deactivates the Kubernetes deployments, and it exposes a rich set of metrics which is used to drive the horizontal pod autoscaler. And in terms of different auto scaling infrastructure or auto scaling support, KEDA can work with databases, it can work with messaging services, it can work with normal resources like or normal request like a HTTP request. It creates this scaled object, which is the main link between your target and the event source. And KEDA recently moved from incubation project into sandbox project. So if you know the CNCF, or Cloud Native Computing Foundation, which is one of the foundation helping cloud native projects, it's an umbrella of projects. It manages all these cloud native projects which are used for development of cloud native applications. They have different stages through which a project progresses. So currently, KEDA is moved from a sandbox to an incubation project, which means that more and more people are using KEDA, and there is a lot of support for KEDA. So we looked at this scaled object definition. So what is highlighted here in the screen is the main things, like its type is scaled object. The target that it scales is a deployment, and the type in our example is RabbitMQ, and some additional properties related to RabbitMQ. So this is what we saw in the live demo. We had the RabbitMQ producer service producing certain number of messages. Then KEDA was there, which was linking the custom resource scaled object to the event source of RabbitMQ, and it scaled within that range of 0 to 30 instances. Some of the features of KEDA project, they include, it is event driven. So nowadays, if you see, we are moving away from a batch based processing, and we have a lot of focus on developing APIs, microservices, and you hear a lot about event driven architecture. So things like serverless are playing quite an important role in all these modern technologies, and KEDA has features which enable these event driven scaling. It makes auto scaling very easy. It has set this built-in out-of-box support for more than 45 different types of scalars, which we will see soon. So it makes it very easy. We don't have to create custom resources. We don't have to create our own projects by using these SCADA out-of-box scalars. I said about the built-in scalars. They can do scaling for vendor-driven solutions as well, including databases, messaging, telemetry systems like Prometheus, which is again quite important in terms of areas related to CI/CD or SRE, for example, for improving the observability of the system. It supports multiple types of workloads. So we saw deployment as the type which was used for scaling, but it also has support for scaling jobs if we are using Kubernetes jobs. It is vendor agnostic. So being an open source solution, we don't have any tie-up with any vendor. As long as your Kubernetes cluster is 1.16 and above version, we can work with KEDA. And from a serverless point of view, Azure function support is also there. So we can use Azure functions and scale those functions using KEDA. So let's look at some of the event sources and the scalars. Since this project was initially started by Red Hat and Microsoft, so there is support for a lot of Azure services like Azure Blob Storage, Azure Service Bus Queue, Azure Event Hub, Azure Log Analytics, Azure Storage Queues. When it comes to other clouds, there is AWS and GCP support. In AWS, there is AWS CloudWatch, Kinesis Streams, and the SQS service. And GCP has support for GCP PubSub. In terms of messaging or similar kind of applications or products or projects, there is support for Kafka, ActiveMQ, RabbitMQ, then Redis, Lakeless, Prometheus, for example. These are again like mostly used in nowadays for building distributed applications and highly scalable applications. And in the databases section, we have support for MS SQL. There is Cassandra, MongoDB, PostgreSQL, MySQL, and this list is growing day by day. When I started looking at KEDA about 3 years back, I think there were only 6 or 8 autoscalers. Now it has grown to about 45 or 50 different scalars. So I provided a link here to the latest version 2.5 and the scalars that it has. You can go and refer to that if you want to use any of these scalars. So in summary, what we saw during this demo is KEDA is very lightweight. It doesn't do too many things. It focuses on only one thing, which is doing event-driven auto-scaling, and it does it very well. It can support any Kubernetes cluster, which is 1.16 or higher. it extends the Kubernetes event-driven capabilities. So there is some sort of capabilities within Kubernetes by means of that horizontal pod autoscaler, for example. But where it is not sufficient to use the default HPA, this KEDA helps to extend those capabilities. And it doesn't override or duplicate any of the existing functionality. If I want, I can go back and delete those resources which were created by KEDA. Whatever I did by means of running that deploy autoscaler, the three manifest files, I can delete those three objects and I can go back to the way my application was working before. So the application doesn't even have to know that there is KEDA existing in the Kubernetes cluster. If it doesn't want to use it, let's say at a later point in time, you realize that there is a better project coming up and you want to use that, the impact on your application is very minimal. You don't have to make any code changes to the application to work with KEDA. And it maps the event source to different types of Kubernetes objects. Like we saw deployment, it can also scale stateful sets, jobs, or even custom resources. And it's very flexible. It can run alongside other Kubernetes frameworks or applications. And as of this morning, there are more than 45 autoscalers which are supported out of the box. If you're looking at some of the other alternatives to KEDA, because this is a common problem, what I showed you, which is scaling based on events. You don't want to have Kubernetes deployments or Kubernetes objects running and occupying resources on your Kubernetes cluster. The whole thing about cloud native technologies and cloud in general is that you should be able to save cost and optimize cost. So if you want to scale down certain things, there are other projects available which you might want to have a look at. There is Knative, there is Apache OpenWhisk and OpenFast. The OpenWhisk and OpenFast, they are trying to do more of functions as a service, fast or serverless functions which can be deployed on any platform. Knative has a wide array of facilities, so you might want to look at these projects if you are evaluating these kind of things. For the references, I would suggest that if you want to know more about Docker or Kubernetes and you don't have enough resources on your laptop, you can use this browser-based things to learn more. There is Play with Docker and Play with Kubernetes. There are also some learning courses which I have shown here. When it comes to what I showcased during this demo, I've given the links to the KEDA project, which is basically keda.sh. Then the AKS cluster autoscaler, horizontal pod autoscaler, and the other three options that we talked about. If you want to learn more about Kubernetes per se, there is a very good resource which I found useful when I was learning Kubernetes. It's called 50 Days from Zero to Hero with Kubernetes. It is done by or published by Microsoft, along with the co-creator of Kubernetes, which is Brendan Burns. And it's a series of short YouTube videos, bite-sized videos, which you can easily watch within 5 to 10 minutes while you are munching some food or you're taking a short break. And it also gives you references to other links. And then if you are more of a guy who wants to do hands-on and you want to learn more about Azure Kubernetes Service, which is the managed Kubernetes service, there is also a learning path on Microsoft Learn, which you can refer to. And finally, my own YouTube channel has various resources. When I started the channel about 1.5 years back, the first thing I did was a three-part KEDA series. So whatever I showed you now is available as a three-part series on my YouTube channel, which tells you how to provision a cluster, how to deploy KEDA, all those things are explained there. Even before that, I did a 6-part series for the Azure Singapore user group to learn about Kubernetes, which is the AKS learning series. And then I regularly post about different things related to Azure and Kubernetes on my YouTube channel. So feel free to subscribe to this and share it with your friends. The source code and the slides, they are already published. Source code is available on GitHub. If you want to do the demo, if you want to replicate this demo, I've created a markdown file in the GitHub repository. You can follow the steps there and you will be able to replicate all the steps that I showed you here on your own environment. So in case you joined in late, My name is Nilesh Phule. It's quite unique combination of first and last name, and for me, it's very easy to find this combination to create new IDs on any of the social media platforms. So you will find me on LinkedIn, Twitter, GitHub using the same name. Uh, and except for my blog, which is Hands-on Architect, I'm available using same handle in all the social media. So feel free to connect with me if you found this useful or you want to have some discussion. I just mentioned that you are part of this particular session, so I know that why you want to connect with me. So with that, I conclude this session. Thank you. Thanks a lot for joining in. If there are any questions, I'm happy to take them.
Thank you. Wow, it's a great session, Nilesh. It's a very insightful, very informative session, actually. So, guys, if you have any questions, so you can comment below in the YouTube channel. So, Nilesh can give the answer of all. Okay, so I think that as of now there is no question. So, guys, if you have any question related to this session, so you can comment below. So, like Nilesh will give you all those questions answers. So, and uh, and we have already shared the slides of the session, so if you wanted to have, you can download from that link, so that is available in the comment section of this channel. And so thank you, Nilesh. So I think that there is no question as of now. So yeah, so thank you so much for joining this session. It's a very wonderful session, and I hope that everyone will going to like a lot from this, learn a lot from this session actually. And guys, uh, if you learn something from this session and you wanted to know something more about this session and wanted to learn something more from the Nilesh, so there is a YouTube channel is also there, and Nilesh is also mentioned this YouTube link, and it's already there in the comment section, so you can go and subscribe this channel and keep learning and keep sharing. Okay, so thank you so much, and happy weekend, Nilesh. So thanks a lot. Thank you. Bye.
Thank you. Thanks for this opportunity.
Yeah.
Have a nice day.
Bye.
Bye bye.
Bye.